Last week, we stopped right before we got to part B for the worksheet we were working on for 2.3. Beforehand, we were talking about two different companies that sold t-shirts, Mighty and No Shrink. Mighty has the equation y equals 4, y equals x plus 49, and No Shrink has y equals 4.5 times x. And part B introduces a new company called the Big T. And instead of giving us an equation, they gave us a table to represent their information. So when I asked to compare the cost for this company with the cost for the two companies in part A, here's our two companies for part A. So what we can compare is our intercepts, our y-intercepts. We can maybe look at whether or not both the rates are increasing, and maybe even the constant rate of change, whether all three are linear, or maybe they might even have the same rate. So these are some things that we can compare. Now, does this plan represent a linear relationship? Well, we can use what we know about tables to see if there's a constant rate of change. So what would help is trying to figure out the differences between each one. It's a little challenging because we're used to our numbers going up by 1 for our independent variable. So like 0, 1, 2, 3, 4. But it's not, so we're going to have to work with that. So for example, the difference between 0 and 3, that would just be 3. And the difference between 34 and 41.5 is 7.5. So right now we know that for 3 shirts, the cost is $7.50. Now what we can do with that information is compare it to the rest of the information and see if maybe there's a pattern that's showing a consistent change in shirts and money. So that'd be a good start off point. Could the point 24.48 lie on the graph of this cost plan? Well, the point 2048, that's just the point XY. So if we look over here, our top rows are X and our cost is our Y. So when they say, does 2048 work with this table? Let's just put it in. Let's see how it looks. So we have 2048. So if we look at that, we go 0, 3, 5, 8, 10, 20. That's kind of a big jump, but that's okay. We're just looking at them right now. So if we notice, when we go up in our number of shirts, so does our cost. It's going up each time. It's increasing. But when we go from 10 to 20 shirts, we don't seem to be going up anymore. We seem to be going down. So the question is really asking, for 20 shirts, would it cost $48 with Big T's table? Would it make sense for the cost to be $48? So you have to look at this table and explain why you think 2048 works with this table or not. And then what information about the t-shirts and cost do the coordinates of the point 2048 represent? Well, based on how we put in our table, 20 is in the top row with our independent variable, number of shirts, and 48 is in our bottom row with our cost. So that's what those two numbers represent.